Hello guys, so this is a video for week 24 class. So in this video, I'm going to finish off what we didn't have time to finish last Saturday. Okay, so we're going to start with point slope form because obviously there are a lot of students who feel confused with this concept. So in order to get to point slope form, I want to give you a big picture. So what exactly is point slope form? So when we study linear relation, we should know that linear relations and straight lines, I think I've said this multiple times in class. In mathematics, linear relation and straight lines, they're mathematically equivalent. So when we talk about linear relation, we are basically talking about straight lines. Okay, so these two things are basically the same. Okay, so linear relation is the algebraic representation of straight lines. Okay, and the straight lines are the geometric presentation of linear relation, but they're essentially the same thing. Okay, so if we have a straight line, we have different forms with different ways of expressing this straight line using linear relations. Okay, so there are different forms. So we have different forms. Different forms means we have different ways of expressing straight lines. Okay, we have standard form. Okay, this is a standard form. AX plus BX plus C is equal to 0. ABC, they're all real numbers. Or we have point slope form. This is a second way of expressing a straight line. We can use a point on the straight line and the slope of the straight line. And this is the expression. So y minus y1 is equal to m times x minus x1. Here, the m is the slope of the straight line. M is the slope of the straight line, and x1, y1 is a given point on this straight line. Okay, so this is the most important one that we need to study in this class. Okay, I repeat this. So point slope form, after all, is just a way, a method of expressing a straight lines using numbers and letters. Okay, and in this form, y minus y1 is equal to m times x minus x1. In this expression, m stands for the slope of the straight line, and x1, y1 is a point that is given. So with these two pieces of information, we can write the straight line using this form. And then we have almost the most common way of writing a straight line or a linear relation, which is slope-intercept form. Y is equal to mx plus b. So here, m is also the slope of a straight line. And here, b is called the y-intercept. But this is not part of our class today, so I'm not going to talk too much about it. Okay, the reason why I want to show you these three different forms is that I want you to know, I want you to have an idea that whatever we're learning today, it's not something like mysterious. It's not something out of nowhere. It's just one of the three methods that we can use to express a straight line. Okay, so today we're going to focus on the second one, point slope form. So let's see what point slope form is. Okay, I drew a graph here. Okay, I drew a graph here. In this graph, we can see there is a straight line, right? There's a straight line. I call this line L. Okay, this line's name is L. So now I have, imagine we only have two pieces of information. We only know two things about this straight line. the first thing we know is the slope. The slope of a straight line is equal to m, okay? And we also know there is a point. This point is given, okay? And the coordinates of this point are x1, y1. So these two pieces of information are given. Slope is equal to m, and there's one point on this line, which is x1, y1. I want to recall something that we have learned in the past 2 weeks, okay? How do we determine the slope of a straight line? We choose any 2 points on a straight line, right? So in order to, okay, I'm going to draw another graph here just to make it clear. So if we have a straight line, right, how do we determine the slope of the straight line? We choose any 2 points on this straight line, right? So this point, for example, it's x1, y1. And this point is x2, y2. And we know the formula for slope. The slope formula is equal to y2 minus y1 over x2 minus x1, right? So this is what the point slope form is based off, okay? The slope formula, this is what the point slope form is based off. Why? Let's see. So now we know for this straight line, we have a slope m, and this point is given, right? We know that if we choose any other point on this straight line, any other point on this straight line, we can find the slope m, right? Any point on the straight line, with any point on the straight line, we can express the slope m. There are many other points on the straight line, like millions of millions. So we can't express each of them. That's why we use a general form, which is x, y. Okay. So the x, y here, it doesn't represent this specific point. It represents all the points on the straight line. It can be this one, 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 it can be any point on this straight line. Okay. And we know as long as we have any other point on the straight line, we can use the slope formula to express the slope. How do we do that? So the slope m, if we know this point is given, and if we know any other point on the straight line, which is coordinated by x and y, the slope formula is m is equal to y minus y1 over x minus x1, right? So here, we are basically using this given point and any other point on the straight line, okay? And then we use, so now it's just basic algebra, right? We time x times, as our x minus x1 on both sides of the equation. Right? And this is called the point slope form. This is called the point slope form. So this is how the point slope form is derived from the slope formula. And this is the point slope form. Okay. So let's just look at this again. what is point slope form and how do we derive it from the slope formula? Okay. We have a given point, x1, y1. So when we see our examples and we see our homework questions, we will realize that for each of this type of question, there has to be one point that is given. Okay, there has to be one point that is given. And the slope of a straight line must be given too. With these two pieces of information, we express any other point on the straight line as xy. So xy here, like I said, this is not a specific point. When we say xy, we don't know which point it refers to. We know this point lies on the straight line, but it's not a specific point. Okay, and we use the slope formula. X is equal to y minus y1 over x minus x1, and then we just do a little bit of manipulation, and then we get this form. And this form is called the point slope form. Okay, so let me give you some examples. Okay, so examples here. Examples. Okay, for example, we know a straight line. Okay, so let's call this example 1. So for example, we know a straight line. Let's call this line L1. Okay, we know L1 has a slope m is equal to 2. And we also know that point A, let's say 2, 4, is on the straight line, is on L1. Okay, and then now the question is asking us to find, so let's say the question says, find the expression let's use like more professional language. Let's say find the linear relation. And express it using point slope form. Okay, so for the first example, in order to visualize this, I'm going to draw a graph. Okay, I'm going to draw a graph. So now we have a straight line, right? The graph is just for understanding. So it might not be like super accurate, doesn't matter. Okay, so let's call this L1. Okay, so what do we know about this straight line? We know two things about this straight line. We know the slope is equal to 2. And we know point A, which is 2, 4, is on the straight line. So 2, 4, let's say this is 2, 4, this is A, 2, 4. Okay, how do we find the linear relation of the straight line? We use the slope formula, right? We know if we know any other point, for example, if we knew this point on this straight line, if we know this coordinate, then we can use the slope formula to find the slope, right? To express the slope So we can say the slope m is equal to 2, which is equal to y minus 4 over x minus 2, right? Like I said, this point, we can say this point is xy. We can say this point is xy. We can say this point is xy. It doesn't matter. Why? Because we learned in last class or 2 weeks ago, any 2 points on a straight line, with any 2 points on a straight line, we can find the slope. We can express the slope. So it doesn't matter if it's this one or this point or this point. That's why we can generalize their coordinates using x, y. Okay, so here we have 2 is equal to y minus 4 over x minus 2. And now we just multiply x minus 2 on both sides of the equation. And we find 2 times x minus 2 is equal to y minus 4 over x minus 2 times x minus 2. So x minus 2 cancels out, right? So y minus 4 is left. So this is the point slope form of L1. Okay, this is the point slope form of L1. Let's do another example. It's all about practice. Let's do another one. Example 2. Okay, so I'm not going to write all the words of the question. Let's just write down all the important information. For example, another straight line L2 has a slope of, let's say, minus 5. Okay, and point B, let's say 2, 9 is on a point. Oh, sorry, it's on a straight line. Okay, this time I'm not going to draw any graph. Okay, because I want you to start to deepen your understanding of slope point slope form. Okay, so now we only have these 2 pieces of information. Easy. And okay, so we know this straight line is there, right? And we already know 1 point on the straight line, which is 2, 9, point B, right? We just need another point on the straight line whose coordinates can be generalized to xy. So we have another point, xy, which is also on L2. So we use the slope formula. M is equal to minus 5, which is equal to y minus 9 over x minus 2. And here we use some algebraic manipulation. We multiply x minus 2 to both sides of the equation. We have minus 5 over x minus 2 is equal to y minus 9 over x minus 2 times x minus 2. X minus 2 cancels out. So we have y minus 9. Okay, so this is the point slope formula. Sorry, point slope form for this straight line. So if you understand what's going on here, everything seems easy, right? So we really need to understand what point slope form is. After understanding what it is, we can do this kind of questions very quickly without any effort, because it's just a pattern, okay? Like all the questions like this, they're in the same pattern, okay? So now I'm going to go back to our class notes and let's look at the class practice here. Hopefully this time you will have a better understanding, okay? So let's start from here, because apparently starting from here, like this is where a lot of people started getting confused in this class, okay? So point slope form of a line, given a point on the line x1, y1. So x1, y1 is on the point, and this point is given. This point is given. And the slope of the line m, and the equation of the line may be expressed as y minus y1 is equal to x m times x minus x1. So this is what we discussed, right? And the standard form, I also mentioned this, right? The standard form here, okay? This is the standard form of a straight line, okay? I just want to mention one thing. I think I also said this in class, but just in case some people didn't hear me. These three forms are interchangeable, okay? Because all of them are essentially the same thing, okay? So for one straight line, it can have a standard form, it can have a point slope form, it can have a slope intercept form, but we can change these forms to each other if we want to, okay? So they're essentially the same form as are different forms of the same straight line, okay? So let's look at the class practice. Find the equation of a line through -3, 2 with a slope m is equal to -2. After doing the two examples that I provided, this question seems easier, right? So express the equation in standard form. Okay, so we need to like do it in standard form. Okay, so how do we do that? We have, okay, so imagine, let's use the same language in our example. So, okay, so there is a line, let's call it L1. L1 has a slope, which is -2, and the point A, -3, 2 is on the straight line, right? And we know, so now we have a point, we have the slope. We just need another point that is on the line to express the slope. And we know all the points on the straight line, their coordinates can be generalized as x, y, right? Like I said, it's all the same pattern, right? It's all the same steps. Okay, so now we know m is equal to -2, and this can be expressed as y -2 over x minus -3, right? Because there's a minus sign here already, right? And x minus -3. So this is equal to y -2 over x plus 3, right? And now we just do some algebraic manipulation. We multiply x plus 3 to both sides of the equation. Now we have -2 times x plus 3 is equal to y -2. So if the question asked you to find the point slope, a point slope form of this straight line, then you're done in this step. Okay, I repeat, if the question asks to find the point slope form of the straight line, then to this point, to this step, you're done. But this question asked us to express the equation in standard form. Standard form is ax plus by plus c, which is equal to 0. So we just need to do a few more steps to change the point slope form to the standard form. Okay, we basically move everything to the left side and we leave the right side of the equation 0. Okay, so now we have -2x minus 6 minus y plus 2. Okay, and the other side of the equation now is 0, right? And now we like combine the like terms, and that will be minus 2x minus y minus 4, which is equal to 0. Okay, so technically to this point, we're done. But there's a tradition in linear equation and linear, what is it called? Linear relation and linear equation. We usually don't leave the first coefficient negative. So if the first coefficient is negative, we always change it to positive. Okay, so what we need to do is we multiply -1 to the whole equation, right? And the other side is 0 times -1, which is equal to 0. So it doesn't really change anything, but it can change the whole, like the sign of the whole equation. So 2x plus y plus 4 is equal to 0. So this is the final answer. Okay, this is the standard form of this straight line. Okay. Part B, a lot of people have trouble understanding part B. A lot of people have trouble understanding part B. Let me explain what part B is really asking us. Okay, so let's go back to our notes here. Let's go back to our notes here. So we are given a slope of a straight line, and we're given a point. We basically used these two pieces of information to find the expression of this straight line, right? But how do we know? How do we know whether we found the correct one? What if there is any mistake in our calculation? Okay, so part B here, part B of this question is basically a verification to verify, to make sure that we didn't make any mistakes in our calculation. So we found the straight line, we found the expression of the straight line, right? And now we use the expression that we found using this step to find any two random points on the straight line. If the expression that we found is correct, then these 2 points must lie on the straight line. And if the 2 points lie on the straight line, then the slope of the line segment between these 2 points must be the same as the slope as the straight line. That's the logic behind question part B. Okay, so let's do it. So we found that the expression for the straight line is 2x plus y plus 4 is equal to 0, right? So how do we find different points? We basically take different x values and we find different y values, right? That's how we find different points. So for example, if we let x be 0, if x is equal to 0, then 2 times 0 plus y plus 4 is 0, right? And here we can find y is equal to -4, which means the point 0 minus 4 should lie on the straight line if we didn't make any mistakes in the calculation here, right? So if the calculation is correct here, then this point should be lie on the straight line, right? So this is point P. Point Q, any point, okay. Let's make x be equal to, let's say, 3. If x is equal to 3, then 2 times 3 plus y plus 4 is equal to 0. So 2 times 3, that's 6. 6 plus 4, that's 10. 10 plus y needs to be 0, which means y is equal to minus 10. Right? So now q, 3 minus 10 is supposed to be on the straight line. Now, we just need to verify. How do we verify it? If the slope of this of the line segment PQ, if the slope of PQ is equal to minus 2, then that means we did the right calculation, right? Because these two points, we found these 2 points based on the straight line expression that we found using these 2 pieces of information. So we had this, and we found this expression, and we found these 2 points. So if there's no mistake in our calculation, then the slope of PQ should be the same, should be equal to the original straight line slope. That's a logic. Okay, so now the slope of line PQ, line segment PQ, is equal to, remember, y2, this is always the same. Okay, the slope formula is always the same, y2 minus y1 over x2 minus x1. So we have minus 10 minus minus 4 over 3 minus 0. So minus 10 minus minus 4, that's minus 10 plus 4 over 3, which is minus 6 over 3, which is minus 2. Okay, verified. This means the calculation that we did is correct, which means this expression is the one that we were looking for. Okay, so this means the straight line that passes through minus 3, 2 with a slope m is equal to minus 2. This straight line, okay, this geometric shape can be algebraically expressed by this expression. They are equivalent. Okay, you need to have this one-to-one mapping between the straight lines and linear relations. Okay, because these 2 things are essentially the same thing. Okay. Okay, now let's move on to the last page. Equations of line 2.4. Okay, so we can determine the equation of a line given 2 points on the line. This is pretty much the same thing as point slope form. There's just one more step. Okay, when we have 2 points, okay, so for example, when we have 2 points, let's say 0, 2, and 5, 3. When we have 2 points on the straight line, instead of using the slope right away, we have to find the slope first, right? So with point slope form, the slope is given. The slope is given, right? This is why it's called point slope form of a straight line. But with 2 points, 2-point form, this is very this is not very common. Okay, but with 2 points, we have to use the slope formula to find the slope first. And then we use the same method to find the straight line expression. Okay, so we use the slope formula first, y2 minus y1 over x2 minus x1, and we'll find a number, right? And we can pick either of these 2 points to find the expression of the straight line. Okay, let's look at the example. So example says, find the equation of line through -3, -1, and 6, 5. Express the equation in standard form. Okay. So instead of using the slope like immediately, we don't have it, right? So we have to find the slope first. So the slope is equal to y2 minus y1 over x2 minus x1, which is equal to 5 minus 1 over 6 minus 3. So this is 6 over 9, that's 2 over 3, right? And everything else is the same as point slope form. Okay, so now we have the slope, now we have 2 points. We can pick either of them. Okay, so we can use this point or we can use this point. We just repeat the steps that we did in the last section. Okay, so m is equal to 2 over 3, right? Which is equal to y minus, let's choose this point, -1 over x minus 3. So this is equal to y plus 1 over x plus 3, right? Now, we need to get rid of the fraction, right? We need to get rid of the fraction. So we can, first step, we can multiply 3 to both sides of the equation. So 2 is equal to 3 times y plus 1 over x plus 3, right? Now we need to get rid of the denominator on the right side, which is multiply x plus 3 to both sides of the equation. This becomes 2 times x plus 3 is equal to 3 times y plus 1, right? And now we open all the brackets. We need to express this in the standard form, So like I said, we need to move everything to the left side and leave the right side 0. So 2x plus 6 minus 3y minus 3 is equal to 0. Okay, 2x minus 3y plus 3 is equal to 0. Okay, so this is the final answer. So as you can see, the 2-point form and the point slope form, the two point form just has one extra step than the point slope form, which is in the 2-point form, we need to find the slope using these 2 points first. And then we can pick either of the points to find the expression of the straight line. Okay, so other than finding the slope of the straight line, other steps are essentially the same. Okay. Okay, so let's quickly go over the class practice. I actually don't really like this question because it's not very typical. It's horizontal and vertical line. Okay, but let's see. So first, -3, 5 minus 3, slope. We know that slope formula is y2 minus y1 over x2 minus x1, which is -3 minus -3 over 5 minus -3, right? -3 minus 3 is equal to 0. 0 over anything is 0. So the slope is 0. Okay. Point slope form. So now we have the slope, which is equal to 0, right? We can find the point slope form. We can choose either of these 2 points, right? So we can say y minus -3. Okay, so let's choose this point. Let's choose this point. So y minus -3 over x minus 5 is equal to 0 because slope is 0, right? So now when we multiply x minus 5 to both sides of the equation, it's y minus -3 is equal to y plus 3, right? Is equal to x minus 5 times 0. That's just 0. So this is just the point slope form. I mean, you can write it like this. Actually, this might be a better answer because it's more of the form, right? Y plus 3 is equal to 0 times x minus 5. So that's a point slope form. Standard form. Now we know this side is equal to 0, right? So the standard form is just 0x plus y plus 3 is equal to 0. So it's just y plus 3 is equal to 0. And we know this line is horizontal. Okay, this line is horizontal. When we draw like the graph, in the coordinates plane, okay, x, y. Let's say this is 3. So the straight line represented by this expression is like this. So this straight line is y is equal to minus, oh wait, sorry, my bad. So y plus 3 is equal to 0. This can be written as y is equal to minus 3. So the straight line should be this one. Okay, this is minus 3. So this straight line is y is equal to minus 3. So all the points on this straight line have the same y coordinate, which is minus 3. But all the points on the straight line have different x coordinates. Okay, so this is the geometric presentation of a horizontal straight line, right? When we say y is equal to minus 3, that means all the points have the same y coordinate, which is minus 3, but all the points have different x coordinates. So for example, this point is 0, minus 3. This one is 1, minus 3. This one, 2, minus 3. Minus 5, minus 3. So all the points on this straight line have the same y coordinate, but different x coordinates. And that is called a horizontal line. Okay. And now let's look at the last part of this class. 4 minus 3, 4, 6. Let's try to find a slope. So slope is y2 minus y1 over x2 minus x1. So it's equal to 6 minus 3 over 4 minus 4. So it's 6 minus 3, that's 9, right? 9. 4 minus 4 is 0. You know, any number divided by 0 is undefined. So there is no slope. So the m is undefined. M is undefined. Because m is undefined, because there's no slope, there is no point slope form. So there is no point slope form. Okay, because point slope form only exists. It only makes sense to have a point slope form when we have a slope. if the slope is not even defined, then there's no point of having a point slope form. Okay, and standard form. So for this, the standard form, we can see for these 2 points, okay, the x coordinates are the same. Y coordinates are different. Okay, so the standard form, so the line that passes through these 2 points can be written as x is equal to 4. So this expression, this equation means on this straight line, all the x coordinates are the same, which is 4, and all the y coordinates are different. And this can be written as x minus 4 is equal to 0. And this will be the standard form. X minus 4 is equal to 0. If we want to draw this in a graph, then it will be like this. So this is x-axis and this is y-axis, okay? This straight line, this is x is equal to 4. Why? Because we can see all the points on this straight line have the same x coordinate. For example, this point, we can tell the coordinate is 4, 0, right? Maybe this is 4, 1, 4, 2, 4, 5, 4, 10, 4, 20, etc., right? And on the negative side, 4 minus 1, 4 minus 2, etc., etc., etc. So all the points on this straight line, they have the same x coordinate, which is x is equal to 4. And but the y coordinates are all different. So this is a vertical line, okay? So I want you to remember this, okay? Because this is a very important, conclusion to remember, okay? All horizontal lines, all horizontal straight lines have the slope equal to 0. All vertical lines do not have slopes. In other words, slopes of vertical lines are always undefined. Okay? Okay, then this is the end of the video. I hope this is helpful for you to understand our materials. Okay, and like I said, other videos will be uploaded soon. Okay, have fun studying.